Hello students, today we will discuss about JEE Mains 2015 physics paper. Now we will discuss all the questions one by one. Okay, let us start. Students, now let us solve next question, question number 11. Consider an ideal gas confined in an isolated closed chamber. There is a closed chamber and the gas is enclosed, confined. This gas is ideal and the chamber is isolated from the surrounding. So isolated is basically adiabatic process. So adiabatic, no heat can exchange, can leave or enter the system. As the gas undergoes an adiabatic expansion, the gas undergoes adiabatic expansion. The average time of collision between the molecules increases. So average time of collision, that is the relaxation time. Average relaxation time. This is the average time of collision. Sometimes this is called as average relaxation time. That relaxation time between the molecules increases as it. So this it says that is proportional to V raised to Q, where V is the volume of the gas contained here and Q is any number that you have to find. Then the value of Q is. So the Q is to be found. Now to solve this, we have to know the formula for this formula for the relaxation time and the mean free path. So depending on that, we'll solve the question. So I'll do one thing. I'll take time, because we know that speed is distance by time. Okay, speed is distance by time. So time will be distance upon the speed. Now distance, the mean free path upon the speed of the molecule. Now the mean free path, this is the mean free path and this is the average speed of molecule. Now then I have to find the value of lambda. The lambda formula is something you have to understand. That is, if it is not known, then you have to derive the expression for lambda. If you have forgotten, then you derive the expression or you just write the formula. Lambda is root 2, okay, 1 upon root 2 n pi d square. This is the formula for lambda, mean free path, which is this, where this n, small n, is the number of molecules per volume. This capital V stands for volume, this small v stands for speed, n is the number of molecules. Number of molecules. So this n is n by v. If I substitute that here, and d is what the diameter, and if I put this here, then this is v of comes of root 2 n pi d square. You can see from here that this lambda is proportional to v with volume. Lambda is proportional to v. And what about this small v? This is one part. I am talking about lambda now. When I talk about this speed of the molecule, this is proportional to square root of absolute temperature, because from kinetic theory of gases, there is the average kinetic energy is found to be 3 by 2 RT for 1 mole of gas, or this is half m v square is 3 by 2 RT. This is obviously the root mean square speed. From here, the v is proportional to under root of t. You can rearrange and get this expression. So from here, this is the case that v is proportional to under root of t. But then I have to have the relationship between that tau and v. So here this is expressed in terms of v. This also should be expressed in terms of this v. This v is proportional to root of t, but because it is an adiabatic process, so we have tv raised to gamma minus 1 is constant. So t is proportional to v raised to 1 minus gamma. From here, from this expression, you can write like this. Okay. There is another expression for also adiabatic process that are frequently used is Pv raised to gamma is constant. This is for adiabatic process. But this is the formula used when you talk about the pressure and volume variations. This is the formula used when you talk about the temperature and volume variations. So we are interested here in terms you want to replace this t in terms of v. So therefore you will use this expression, and these two product is constant, so this is proportional to v to the power 1 minus. This will change because this will come to this side and goes off. This will become 1 minus. So if I put this here, then I'll get the speed is proportional to v raised to 1 minus gamma. In place of t, I will write this, and the power is there half, so this is divided by 2. This one expression, this second expression is put here in the first one, like tau is lambda by v. So tau is lambda by v, and v. So lambda is proportional to v, and this small v is proportional to, now you got just now, small v is proportional to v raised to 1 minus gamma divided by 2. Now this actually is proportional to that. So if this is this, then this is proportional to this. So this is proportional to, this is v, and this goes off. When this goes off, this will become minus, the sign will be changing. So this is minus. So this becomes plus, this becomes minus. This is gamma minus 1 divided by 2. This power is 1. So if you solve this, this becomes power is 1 plus gamma minus 1 and divided by 2. This power is, you have to add the power. So like this, and finally you will get what? 2 plus gamma minus 1 divided by 2, proportional to 1, 2 minus 1, so is 1 plus gamma divided by 2 and the power of volume. So v raised to what is, so from here t is proportional to this and this tau is proportional to this, and the question, the tau is proportional to given is v raised to q. The question, the tau is given v raised to q. So if you compare these two, q is equal to 1 plus gamma by 2. If you look at the options, so this is the correct options, 1 plus gamma by 2. So this is the answer to this question. Okay, thank you.